Good morning, everyone. Hope you all are fine. In the last class, we had studied about the natural number, the whole number, the integers, and also the rational numbers. Before moving further, let us just revise what we had studied and a few doubts that you might have, or the questions that you must be able to answer if somebody asks you regarding this chapter. So, the first question: are all the natural numbers whole numbers? Are all the natural numbers whole numbers? First of all, answer me, how do we represent natural number? Which alphabet is used? Yes, N. N for natural number. So easy to remember this. So we represent all natural numbers by the capital letter N. So the question is, are all the natural numbers whole numbers? Yes or no? The answer is yes. All the natural numbers are whole numbers by default. See, we represent natural number by capital letter N. This is N, this is sign of equals to, and this is what? This is opening of a set. Set is a collection of items. So natural number N contains 1, 2, 3, 4, 5 and so on till infinity. Okay, that's right. And what about whole numbers? Whole number is represented by W. It is a set of 0, 1, 2, 3, 4, 5 and so on up to infinity. So you see the natural number starts from 1 goes to infinity, the whole number starts from 0 and goes to infinity. So are all these numbers included inside this? Is it? Although it also has an additional number 0, but it also includes all the numbers that are given in the natural number. So all the natural numbers, every element of this natural number, every element of this set, this collection is a part of this whole number by default. So this question was too easy, and now again, are all the whole numbers natural numbers? Are all these elements present in the upper one? No. 0 is a whole number which is not present in the natural number. So saying this, that all the whole numbers are natural numbers, will be what? Incorrect. All whole numbers cannot be natural numbers, but all natural numbers are definitely a whole number. Now, are natural numbers negative or whole numbers negative? No, because when you draw a number line, you take origin at 0, you move towards your, which side this is? This is right side. So moving towards right, you get 1, 2, 3, 4. Will you ever find negative number in this way? In this direction you do not have any negative number. Where do you find negative number? This side. -1, -2, -3 and so on till minus infinity. And this side towards in plus infinity. Plus infinity, or you say infinity, whenever there is no sign mentioned, this is positive. If we say 4, this is same as saying plus 4. When I say -4, this means this magnitude will remain 4 4, but the direction will be opposite. So when there is no sign, it is positive. Where will be? So the natural number starts from here, goes in this direction. Whole number starts from here 0 and goes in this direction. Can you find anything negative? No. So natural numbers and whole numbers cannot be negative. So 3 questions are easily answerable by you now. You can answer them. If anybody asks you, can integers be negative? Right, integers can be negative. Integers include what? Both. It includes 0, the natural numbers, and negatives of natural number. This is what I had already taught you in the next class, in the last class. So you must be knowing that the integers also include the negative numbers. So again I am asking you, can integers be negative? Yes, the integers can be negative. Integers are represented by which alphabet? Yes, by capital letter Z. Z represents integers. So we had studied about natural number, we had studied about whole number, we had studied about the integers, and we also had studied about the rational number. This rational number includes all of the above 3. Whole number includes natural number. Okay. The integers include the whole number, and rational number includes the integers. So the sequence goes like this: natural number, whole number, integers, and rational number. Clear up to this? Should I move forward? Okay. Next, coming on to the rational number. What are equivalent rational numbers? First of all, what is rational number? Yes. The first question arises, what is rational number? Did you remember what I have taught you? It was too simple. There is one numerator, there is one denominator, and that's it. But there is a case that q should not be equal to 0. Why? Because division by 0 is not defined in mathematics. I told you about this. So rational number is a number in the form of p by q, where q is not equal to 0 and p and q should be what? Integers. These are integers. So any integer in numerator, any integer in denominator, and q is not equal to 0, then it is a rational number. Although there may be numbers which cannot be represented in the form of p by q, which we will study later on when we will be studying about the irrational numbers. In the next class, we will study about the irrational numbers. Suppose root 2, what? Root 2 is irrational. Pi, this is also irrational. Before moving that, I will be teaching you about what are non-terminating, non-repeating decimals and all. So that is for the next class. Leave it. Today, rational numbers. Rational number is represented by capital letter Q. So we are starting from equivalent rational numbers. What are equivalent rational numbers? See, this is a rational number. If this is integer, p is integer, q is integer, and q is not equal to 0, then definitely it is a rational number. Provided p and q are integers and q is not equal to 0, it is a rational number. But 2 by 3, this is a rational number. 4 by 6, this is also a rational number. This is also a rational number. 2 by 3, 4 by 6, 6 by 9. These all are rational numbers. What is the difference between them? And what is the similarity between them? Obviously, one difference is that they are different numbers. This is quite obvious. And similarity, they all represent the same number. See, 2 by 3, if I multiply it by 1, is there any change in the number? In mathematics, whenever you divide anything by 1, there is no change in value. The number remains itself. So if 2 by 3 is multiplied by 1, there is no change in the number, it is still 2 by 3. Can I write 1 as 2 by 2? It is again 1. You see, 2 by 2 is 1. Anything divided by itself gives 1. But the value will be changed. It will become 4 by 6. So 2 by 3 is nothing but 4 by 6. What happens if you multiply it by 3 in numerator and 3 in denominator? Instead of 2, it will become 2 3 are 6 and 3 3 are 9. Again, this 6 by 9 is same as 2 by 3 because 2 by 3 and we have multiplied it by 3 by 1, that is 1. So if I multiply 2 by 3 by 1, it will be 2 by 3. And if I multiply 2 by 3 by 1 here, we are getting 6 by 9. What do you infer from this? These are same. So 2 by 3 is equivalent to 4 by 6, is equivalent to 6 by 9, and this is nothing but the equivalent rational numbers. These all are rational numbers but equivalent to each other. That's why they are called equivalent rational numbers. And this form, the basic form from where these all originated, when we had nothing in common, no common factor between the numerator and denominator, that form of rational number is called the simplest form of rational number. Okay, rational number can exist either in the simplest form or in the equivalent rational number form or any other form. But what should be common in them? P should be integer, Q should be integer, Q should not be equal to 0. So equivalent rational numbers is clear. Rational number in simplest form is clear. Two by 7. Is it the simplest form of rational number? Is 2 by 7 the simplest form of a rational number? When I ask you, what will you do first? So first thing first, you will find whether it is a rational number. Even if whether this number is even a rational number. First check this. 2 is an integer. 7 is also an integer. 7 is obviously not equal to 0. This is a rational number. Now, we were asked, is this the simplest form of a rational number? So, is there any common factor between 2 and 7? No. No common factor. So, this is the rational number in simplest form. So, today you got to know about rational number in simplest form and equivalent rational numbers, and moving forward we will be starting representation of rational numbers on number line. See, I already told you this natural number, these all are included inside the whole number, these all are included inside the integers, and these all are included inside the rational numbers. So if you just know how to represent a rational number, you will definitely know how to represent these three also. There is nothing in representing natural and whole numbers. You draw a line You have to represent whole number. It is either 0, 1, 2 or natural number. From here, any digit you can represent. Integers, -1, -2. Nothing to worry, it is so simple to represent. So let's discuss something other than this and this that comes in the rational number. Whenever you are going to represent anything in the number line, draw a number line. What is a number line? OH origin. So what is a number line? A number line is a line where we represent the numbers. As the name suggests, in most of the time in our life, whenever you say a name, the name represents the meaning of that thing. So this is our number line, and we have to represent P by Q. P is an integer, Q is an integer, and Q is not equal to 0. So take a number. Suppose we have to represent 25 by 3. 25 by 3. You have to represent 25 by 3. First, convert this form into, this is a what? This is a fraction form. Is this? This is fraction form. Convert it into mixed form first. 3 divided 25. 3 8 ja 24. What will you get? 1 here. I don't know how many of you still remember. What is this? This thing you must be knowing. This is quotient. Everyone knows it. This is remainder. My handwriting is too poor. Can't handle this. Bear it with me. Remainder. This is quotient. This is remainder. Everyone knows about this. But some of the students forget what is this and what is this. See, what is the operation being done? The operation being done is the division. Who is dividing? Anything that anyone who operates is a operator. Okay. So anyone that divides is a divisor. Who is dividing? 3. 3 is the divisor. And the one on which the operation is being done is dividend. Dividend. Okay. Unless you memorize this thing, unless you understand this thing completely, you won't be getting one important formula of mathematics, that is dividend equals to quotient into divisor plus remainder. How this comes? See, how we get 25? 3 8 ja plus 1. 3 8 ja 24 and plus 1. 1 is what? That is left. If this was 24, this was one digit less. It had been 24 and it was completely divisible. 3 times 8. 24. But since this is greater by one digit, 25 it is. This one is left over here. So 3 8 ja 24 plus 1. Divisor into quotient plus remainder, or you say quotient into divisor plus remainder is what? Is dividend. So you got the formula for dividend. And one more thing you must be knowing, that in mathematics, if you have x, y, z and k, you have given any three value and you have to find the fourth value, and you have a formula that interrelates all of them in one simple equation, you can get the value of that fourth number, right? So we have this equation where we have relationship between these four elements, and if you are given the value of any three of them, you can easily find the fourth one, whether you are to find a divisor, whether you are to find a quotient, whether you are to find a remainder or a dividend itself. These are the basic things that you must know. So here we have divided 25 by 3, and what we got? We got 8 whole 1 by 3. This should also remind you about the formula. 8 into 3 plus 1, 25. And what we are doing? 25 by 3. So this is same as 8 3 are 24 plus 1, 25 by 3. We have converted this fraction form into the mixed fraction form. Now things are a little bit easier for us. I should erase everything that I told you while giving you some extra details, because see, in maths everything is interconnected. So this is 8 whole 1 by 3. 8 whole 1 by 3, what does it signify? It signifies the number has crossed 8 and has not reached 9. If you travel from one place to another place and your plan is to reach somewhere else, you have to reach at 9, you started from 8 and you are somewhere around here. So this is what this number also represents right now. Clear up to this? How much part is left? This 8 is complete. We say 8 whole 1 by 3. What does this whole means? Up to 8 you have already covered. And 1 by 3 is what? The remaining portion of the next distance, that is from 8 to 9. If you divide into 3 equal parts, you have traveled the first part. 1 out of 3 you have traveled. So this is 8 whole 1 by 3. If you draw a line between 8 or to 9 and you divide it into 3 equal parts, you have traveled first part out of that 3 equal parts. So where will this lie? Between 8 and 9. Because it has already traveled from 8 and has not reached to 9 yet. So if we draw, remember, always keep equal spacing between 1, 2, 3, 4 and 5 and so on. Because if I say 0 to 1 and 1 to 2, these all are equidistant. So this should also be reflected in your marking. Here I am drawing with free hand, but never draw this with free hand in your examination or in your any paper. Always use scale or ruler, you say. Always use this. It has a marking for your benefit only. That's why they are selling. So 3, 4, 5, 6, 7, 8, here 9, and always try to draw the next part also. What you are representing a number between 8 and 9, so draw 10 also. And this is your y. You must be knowing the property of line that it can extend indefinitely in both the directions. Indefinitely means endlessly. and this thing is represented by the arrowheads. You see one arrowhead at this end and you see one arrowhead at this end. This arrowhead, what does it represent? That this line is not just limited up to this space. This is going up to infinity and this is going up to infinity in both the directions. This is just a part of it, but this line is going in both the directions towards infinity, from minus infinity to plus infinity. So this is our 8, this is our 9. We divide into 3 equal parts. How many divisions you should use? How many marks? Only 2 marks. When you have to draw 4 equal parts, you will be marking at 3 places because it divides 1, 2, 3, 4. First part, second part, third part and fourth part. So how many markings you used? 3. If I say draw 5 equal parts, how many markings you will use? 4. So first, second, third, fourth, fifth. We divide it into 5 equal parts using 4 marks in between. So if I say you divide into n parts, you will draw n minus 1 marks. We have to draw 3 equal parts. We have drawn the 3 equal parts. The first part is this 8 whole 1 by 3. And this is how you will represent 8 whole 1 by 3 on the number line. Clear up to this? And how to represent 8 whole 1 by 2 by 3? This is 8 whole 2 by 3. This 9 is nothing but 8 whole 3 by 3. See, 8 whole 3 by 3. What does it mean? 3 by 3 means 1. This 8 will be added to 1 and it will become 9. That means you have covered all the 3 parts of the remaining 3 part. That means what? You have reached 9. So here we have seen 25 by 3. In this case, denominator was or Q was less than P. P was greater. Now, if I tell you to represent 3 by 7, here P is what? 3, Q is 7, Q is not equal to 0, this is a rational number, both are integers. Where will this line go? How will you, do you even need to convert into mixed fraction? No, you don't need to convert it into mixed fraction. In the case where your numerator is less than denominator, when P is less than Q, your answer is always between 0 and 1. How? See, it is 3 by 7. This number is 3 by 7. If you increase the numerator, you keep on increasing the numerator, it will become 4 by 7, 5 by 7, 6 by 7, 7 by 7, and now it will go and become 1. Till now it is less than 1. Is it negative? No. 3 by 7 is not negative. It is 0? No, it is not 0. Where it is? It is between 0 and 1, somewhere between 0 and 1. So you draw a line. In all such cases, you need to draw a line better say number line xy. Here it is 1, here it is 2. I always told you, try to represent, go beyond what you need to represent or what number you are associated with while representing. So mark till 2. This is between 0 and 1. How far distance it has covered? The number itself is just speaking. I have covered 3 parts out of 7 parts. Now here 7 parts. So how many markings you will draw? 6. And minus 1 I told you. 1, 2, 3, 4, 5, 6. The 7th one is this one only. So third part, it has covered up to this. And this is your answer. 3 by 7. If it was minus 3 by 7, then same thing. It is if it is plus 3 by 7, then it is between 0 and 1. If it is minus 3 by 7, it is between 0 and minus 1. This cannot be lying on this side, no? This will always lie to the left hand side. Negative numbers are on the left hand side. And when it becomes minus 4 by 7, minus 5 by 7, minus 6 by 7, then minus 7 by 7, then it will become minus 1. So it has not yet become minus 1 even. So draw one number extra. This is minus 1, this is minus 2. Remember, here I am not maintaining the spaces, I am drawing it with free hand. When you are drawing, maintain the free space here and here. Maintain the equal space. Maintain this space will be equal to this space. Okay? So, how minus 3 by 7 will be represented? Between 0 and minus 1, how many parts? 1, 2, 3, 4, 5, 6 and 7th itself. 1, 2, 3, 4, 5, 6 and 7th. So, it has travelled third part, same case here, only the sign is negative, that's why the direction is negative, otherwise everything is same. So this is minus 3 by 7. In the same fashion, when we were representing 25 by 3, what it was? I could not remember, nor do I need to remember. It is too simple to crack. You can always crack 3 8 24, 1. 8 whole 1 by 3. So when it was minus 8 whole 1 by 3, what you had done? You had drawn a line. Since it is minus, it will be on the left of 0. 1, 2, 3, 4, 5, 6, 7, 8. And draw one extra. 9, 8, 7, 6, 5, 4. 3, 2, 1, minus, 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 minus. This is going till x. And it has travelled from 8, minus 8 and it has not yet reached minus 9. The case is same, only the direction is reversed because of this minus sign. If you are able to represent the positive one, you can easily represent the negative one because there is only change of direction because of this minus sign. I had already told you minus sign represents nothing but the change of direction. So it has travelled from minus 8, it has not yet reached minus 9. How much distance is, at how much distance it is lying? It is lying at the 1 by 3rd of the distance. So this distance divided into 3 equal parts, the first, the second and the third. It has travelled only up to this first part. And this is your minus 8 whole 1 by 3. Is that clear? Is that clear so far? So we have seen representing the rational number on the number line. We have seen when the numerator is greater. We have seen the case when denominator is greater. Where we have seen the case when both of them are positive, and we have seen the case when both of them are negative. Now left is the decimal number. Decimal number is very easy to represent. Once again I will ask you, how do we represent the rational number? By the capital letter Q. Okay. So representing a decimal number. This is what? Number line? No. This is a line. We have not represented any number on it so far. X, Y. Suppose we have to represent 0.1. Obviously, it has not yet become 1 and it has travelled 0. How much? 0.1. This 0.1, what does it signify? This is 1 by 10. How? If you want to remove this to one position towards the right, you will need to divide by 10. Suppose if a number is in the form of x point y z, you need to remove this completely. You don't want any decimal number. Then what will you do? To remove this to this one position to the right, you will divide it by 10. To shift it from again one place to the right, you will again divide it by 10. So the number of zeros on the denominator will start increasing. You move it 2 steps in one way, in one step, and you provide 1 plus 2 zeros, means 100 here. How does this work? See, we have 78.96. If we multiply it by 10 and divide it by 10, does it affect the number? No, because it is nothing but 1. We can write 1. The number will remain the same. We write something that represents 1. The number will remain same. What this do? This will help it shift here. Okay? And this will be consumed in bringing this decimal to one step right. So the upper 10 is consumed. What you have? Only the denominator part of that 10. Again you have to move it further. Again multiply by 10, divide by 10. This will remain as it is. This will get consumed in moving this. So what you get? You get 7896 divided by 100. This is same at 78.96. So you have your concept ready. In mathematics, your concept must be clear. So this is 1 by 10. Again you have what? Denominator q is less than p. So how we represent the numbers in such cases? This is between 0 and 1, and out of 10 this is first. 1, 2, 3, 4, 5, 6, 7, 8, 9, because 10th is this one. So out of this 10 units, it has traveled only first part. 10 parts are there between 0 and 1, and it has traveled the first part. So this is your 1 by 10 you say, or you say 0.1, both are same. So in this way you can represent the decimal numbers also. If you are given 7.2, then 7 is complete. 0.2 is what? 0.2 is 2 by 10. Okay. Seven plus 2 by 10. 2 by 10 you can easily represent. After 7, where this lies between 7 and 8. You draw 7, you draw 8, divide it into 10 equal parts, and the second part will be 7 whole. Two by 10 or 7.2. Even if you write 7 whole 2 by 10, what it comes out to be? It turns out to be 70. This into this plus this. 10, 7 is 70 plus 2, 72 by 10. Again it is 7.2 only. Okay. So by simply observing that this is 7, this is complete, and this is point, this is decimal part. So convert it into 2 by 10, or divide this by 10, multiply this by 10, remove this, and removing this, while you remove this, this will be consumed, and this will be 72 by 10. You can divide from 10, 72, 7 times 70. What you are left? 2 by 10. What is the mixed form? 7 whole 2 by 10. Again the same thing. You travel from 7 towards 8, and If you divide the path into 10 equal parts, you are on the second part. So this is 7 whole 2 by 10 or 7.2. So this way you can represent any number on the number line. So representing on the number line integers, whole numbers, natural numbers is, and these all are much easy for you. Now our last topic for today, rational numbers between two rational numbers. How do we find a rational number between two given rational numbers? You are given to find a rational number between suppose 7 and 8. 7 is a rational number. Yes, because 7, you can write 7 as 7 by 1. Both are integers and denominator is not equal to 0. Similarly, the case with 8 is also a rational number. In any case, in whatever case it is given, the first thing you should remember is two golden rules I am giving you. First, equalize the denominator. Equalize the denominator. And second thing is widen the gap between the numerators. The more you will increase the gap, the more numbers you are be able to find. So first thing, equalize the denominator. Second thing is widen the gap between the numerators. 7 and here it is 8. It has denominator 1, this has denominator 1. Denominator are same. Equalize the denominator. This case is over. What is next? Widen the gap between numerators. Between 7 and 8. Is there any counting number? No. So we have to, second step is we have to widen the gap between the numerators. How will we do this? See, if we multiply it by 1, nothing will happen. If we multiply it by 1, nothing will happen. Because in mathematics, what happens? Multiplying any number by 1 gives the number itself. So instead of 1, we can write 10 by 10. This is also 1, or form of writing 1. If I write 100 by 100, this is also an art or form of writing 1. Here also 10 by 10. What this became? This became 70 by 10. And this is 80 by 10. From 70 to 80, you have broadened the gap. Now the gap is increased or widened. Although it will be difficult for you to find a rational number between this and this, 7 and 8, but you have an ease of finding a number between a rational number between this 70 by 10 and 80 by 10. It can be 71 by 10, 72 by 10, 73 by 10, and so on. So up to 79 by 10. You want further more numbers between 7 and 8. Multiply and divide it by 100. It will become 700 by 10. It will become 800 by 10. From 701 by 100, 702 by 100, 703 by 100, 798 by 100, 799 by 100. You see, you have so many numbers then. What you have done, you have first equalized the denominator, then you have widened the gap between the numerators. So this way you can find the numbers, the rational numbers between two given rational numbers. if I ask you to represent to find out the rational numbers between 0 and 0.1. 0 is a rational number, how we had already discussed in the last class, because 0 by 1 or 0 by 2 or anything you can write, it will be 0 itself, where this will be numerator, this will be denominator, and the denominator will not be equal to 0. So 0 is a rational number. 0.1, this can be written as 0.1 can be written as 1 by 10. 1 is integer, 10 is also integer, 10 is not equal to 0, so 0.1 is also a rational number. Both are rational number and we have to find few rational numbers between them. What do we do? 0 by 1, 0.1 is 0.1 by 1. We have to equalize the denominator. If we multiply by 10, in numerator and denominator in both these numbers, there is no change, as you have already seen in the last example. This will become again 0, it will remain 0 because any number multiplied by 0 becomes 0. So 10 when multiplies by 0 becomes 0. It is 0 by 10. This will be, decimal will shift to the right, and when 0.1, this decimal shifts right, it becomes 1.0. There is no meaning of any 0 after the decimal, so it is 1 only. This becomes 1, this is 10. Now we have 0 by 10 and here 1 by 10. You are still not able to find a rational number between them easily. So it's better you make it 100, 100, 100 and 100. You get this time 0 by 100, 10 by 100. Now you have, what you have done, you have widened the gap. First you have equalized the denominator, then you have widened the gap. Now between this to this, you have 1 by 100, 2 by 100, 3 by 100, 4 by 100 and so on, 9 by 100. Okay. So you can find few rational numbers or a lot of rational numbers depending on how much you widen the gap between their numerators, equalizing the denominator. In lots of books you will find different methods, multiply by this and divide by this and all that blah blah, but this is the easiest one that you can remember and you can understand so easily. So we have covered up to this. Nothing is left, I think. If you have any doubt, you can ask. This was all about the natural numbers till natural number, whole number, integers and rational numbers. Now irrational numbers. About irrational numbers, we will study about such numbers in the next class. This was it till today. Thank you for watching. If you have any doubt, I am always ready to help you. So see you. Bye bye.